So energy from chemicals in terms of energy change, the reaction can be classified as endothermic or it can be exothermic. So when an energy change occur in a chemical reaction, the reaction can be classified, just 2 minutes. So in terms of energy change, the reaction can be classified as endothermic or exothermic. Endothermic reaction means the reaction in which energy is taken in. Where exothermic reaction in which the energy is given out. So when it release energy, we call exothermic. When a chemical reaction absorb energy, we call endothermic. If endothermic reaction occur, what we observe? We observe because the energy is taken in, so the temperature of the mixture decreases. What does it mean? Temperature of a mixture decreases. Example, you have a container and which is filled with water. This container is having water and the original temperature of the water is 20 degrees initially. You add reactants, say A and B are the reactants. So this one is particle A and the black shade is representing particle B. So what happened if the reaction is endothermic? The particle required energy for a reaction to occur. So what happened from where the particle will take energy? These particles will take energy from the surrounding. And what is surrounding for them? The water, the liquid is a surrounding for them because they are reacting inside the liquid. So these particles will absorb energy from the liquid. So as the particle absorb energy from the liquid, what will happen? The temperature of the liquid will decrease. So if temperature of a substance decreases, it means the reaction is endothermic. Why the temperature decrease? Because energy of a mixture or energy of a solvent or energy of a surrounding is taken by the reactant particles. So they take energy and we are measuring a temperature of a surrounding. So surrounding temperature is decreasing. But if it was an exothermic reaction, then what we will observe? We will observe that the temperature of mixture will increase. So if you have, say, a container which is filled with a liquid, and you have reactant particle such as A and B. So when these reactant particles collide, exothermic reaction means when they will react, they will release energy. So in this example, if original temperature of the water was 20, because when A and B are reacting, they are releasing the energy when they form the product. So the energy which is released is absorbed by the liquid. As the energy release absorbed by the liquid, the temperature of the liquid will increase. Is it clear? the concept of endothermic reaction in which the energy is taken in by the particle, and exothermic reaction in which the energy is released by the particle. In endothermic reaction, the temperature of the liquid, the mixture will decrease. In exothermic, the temperature will increase or rise in temperature. So, few examples related to this reaction, like so if we say anhydrous copper 2 sulfate, anhydrous copper 2 sulfate is added to water, a solution is formed and heat is given out. Which row shows the temperature change and type of reaction? What could be the answer here? A heat is given out. Which row shows the temperature change and type of reaction? So because energy is released, so when the reactant particle react, they give out energy to form a product. So as the energy is released, the reaction should be exothermic. And what happened to temperature change? The temperature will increase. Is it clear? 19, which is the most exothermic reaction? So when you check, first thing, initial is 20 and final is 5, so it is not an exo, it is endo. Initial is 20, final is 32. This is also, this is exo because energy is released, temperature will increase. 25 change to 12, so temperature decrease, it is endo. And 25 to 34, temperature increase, exo. So either B can be answer or D, but the question is which is the most? Most means which is having the greatest change in temperature. So when you check B, it changes from 20 to 32. So the change in temperature is 12. When you check D, it changes from 25 to 34. So it's 9. So which is the most exothermic reaction, which is having the highest or the greatest change?
Mm.
So B is having the greatest change. That's why this reaction is most exothermic. Because they asked both are B and D are exothermic, but the most means the one which shows the greatest change in temperature, not the highest temperature, greatest change in temperature. Is it clear? This example. Okay. In the next question, 10 grams of ammonium nitrate are added to 25 are added to water at 25. The ammonium nitrate dissolved after 1 minute. The temperature is 10 degrees. Which word describe this change? What happened? So which word describe this change? A, B, C, or D? Original temperature was 25. The final temperature is 10. So if the temperature decrease, energy absorbed, it means the reaction is endothermic. You can take the screenshot for this, then we'll move on. Then in terms of bond, also we can classify the reaction as exo or endo. So if the bond break during a reaction, because to break a bond, we have to supply energy. Example, if we have two hydrogen atoms linked with a covalent bond between them. So if I want to break the bond, what I have to do? I have to supply energy, or energy must be taken in. So if energy is taken in, so bond breaking, if you want to separate this into hydrogen atoms and break the bond, so bond breaking is endothermic. And same way, when the particles will try to form a bond, like oxygen try to form a bond with another oxygen, or nitrogen try to form a bond with another nitrogen. So as they try to form a bond with each other or try to form a link with each other, because the particles has to come closer to each other. So if the particle come closer to each other, they should lose energy. Why? Otherwise, if they're moving very fast, they cannot come close to each other, because the particles are moving at high speed and moving randomly. So for particles to form a bond, they should come close to each other. As they come close to each other, they must release their extra energy so that they can come close to each other. So whenever the particles come closer to each other, the energy is given out, and whenever energy released, so they will link with each other and form a bond. So bond breaking, if you want to break the bond, the reaction is, the change is endothermic. If the bond is formed, the change is exothermic. So bond breaking, endo, whereas bond forming is exo. The term exo means exit, from exit means out, and endo means in. So if energy is taken in, we call it endothermic. Energy is released, we call that as exothermic. So how we can identify a reaction from the bonds? Copy this, take a screenshot, and we'll move on. So how to identify whether reaction is endo or exo using bond energies. So how we can identify whether a reaction is endo or exo? By using a bond energy. So reactant side, the bonds will break, because the reactant first, the bonds will break, and then they will form a product. So reactant side, the bond will break. So whenever bond breaking is there, it is endo. And the product side, the bonds will form. As the bonds will form, the reaction will be exo. Then how we can identify whether a reaction is overall reaction is endothermic or exothermic? So if bond breaking energy is more, bond forming, then the reaction will be endo. Overall reaction. And opposite will happen if bond forming energy is more than the bond breaking, then the overall reaction will be exo. How we'll do these type of questions in which we identify the bond breaking and bond forming? Example, in the question it is written H2 example in the question it is written H2 plus O2 gives, or if I start with a simple example, H2 plus Cl2 gives 2HCl. Equation is given to you. Okay. This is the first thing, the equation is given, and the question is identify whether this reaction is endothermic or exothermic, and the bond energies are also given. You don't have to memorize these bond energies. In exam, it will be given to you. So example, hydrogen is 100, chlorine is 170, and hydrogen chloride is 300. And the question is identify whether this reaction is endothermic or exothermic. So identify nature of the reaction. So how we can identify? First step, draw structure to show all the bonds in reactant and product. So first what you will do, so first draw the structure to show all the bonds in the reactant and product. So H2, what H2 means, how hydrogen, because H2 means hydrogen single bonded with hydrogen. Cl2 means two chlorine single bonded with each other, because chlorine belongs to group 7. And HCl, hydrogen chloride, there's a one hydrogen bonded with another chlorine, and how many molecules are there? 2. So there are 2 molecules of hydrogen chloride. First, this part is clear. Is it clear, this part, how we identify the bonds between the substance? Because hydrogen all will form covalent bond. Here all examples are covalent bond. So H2 means hydrogen hydrogen single bond, Cl2 means chlorine chlorine single bond, and HCl means hydrogen chloride single bond, and 2 molecules are there, so we wrote 2. So first, draw a structure to show all bonds in reactant and product. That's the first thing. Then step 2, calculate bond breaking energy from reactants. So how I can calculate the bond breaking and reactant side, because the bonds will break and the product side the bond will form. So bond breaking, so what is the bond breaking? Hydrogen and hydrogen plus chlorine chlorine. And what is hydrogen hydrogen bond? That's given. You don't have to learn these values in exam. It will be given the bond energies. So this is 100. Chlorine chlorine, it's 170. So 100 plus 170, that's make 270. Is it clear? And the unit of bond energy is kilojoule per mole. That's a unit of bond energy, kilojoule per mole. The third step, step 3, calculate bond forming energy from product. So we'll calculate the bond forming energy from the product. So which bonds, hydrogen and chloride bonds are formed and how many of them? 2 of them. So HCl bond and 1 and 2, that's why I multiplied this by 2. And for each hydrogen chloride bond, the energy is 300. So 2 multiplied by 300, which makes 600 kilojoule per mole. Which energy is greater here? The bond breaking or the bond forming? Which energy is greater in this example? So in this example, bond forming energy is more. And I told you, if bond forming energy is more than the bond breaking, then overall reaction will be exo. So here the bond forming energy is more. So if bond forming energy is more than the bond breaking, which reaction is this? Exothermic. Then the step 4, compare the energy change. So compare the energies of bond breaking and bond forming. So in this example, because the bond forming energy is more, so the overall reaction is, so this reaction is exothermic. Is it clear? Any doubt in this example?
Sir,
Yes.
I didn't really understand this part.
Which part? The calculation? Basically,
Yes.
basically what happened when a chemical reaction occur, there is a bond breaking in the chemical reaction and there is a bond forming also in a chemical reaction. So hydrogen is reacting with chlorine and it is forming hydrogen chloride. So when you show the bond in hydrogen, it is H2 means hydrogen single bonded with another hydrogen. And when you have chlorine, Cl2, it means chlorine single bonded with another chlorine. So hydrogen is reacting with chlorine and it is forming hydrogen chloride. For hydrogen to react with chlorine, first they have to break this bond. This bond should break. So to break this bond, what they will do, they will absorb energy. Because the bond breaking is endothermic. Bond breaking always absorb energy or take in energy, or energy is absorbed to break the bond. So the substance, the bonds which are in there in the reactant side, these bonds first will break and they will absorb energy. So first we identify how much energy absorbed by these bonds when they are breaking. They are absorbing 270 kilojoule per mole. Hydrogen absorb 100 joule hydrogen bond, and chlorine bond absorb 170 joules. So total energy which they absorb is 270 kilojoule per mole. But what happens when the bond will break? The new bonds will form. The new bond which is formed here is hydrogen chloride. Hydrogen form a bond with chlorine. So when they will form a bond, they release energy. So this was absorbing 100, this was absorbing 170. So overall energy which is absorbed by the reactant is 270 to break the bond. But when they break the bonds and form new bonds, bond forming is exothermic. So when hydrogen bonded with chlorine, it will release energy. And how much energy is released? 300 by each bond. So if 300 is by each bond, the total overall energy release will be 600. So energy which is given out or released is 600. Energy which is taken in is only 270. So a small amount of energy is taken in and greater amount of energy is released. So which change is more? Energy release is greater than energy absorbed. That is why this reaction is exothermic reaction. So whenever a chemical reaction occurs, the bonds will break and some new bonds will form. You have to identify that which of the energy is more. When bonds are forming, it is releasing energy. When the bonds break, it is absorbing energy. I'll give another example. Take the screenshot of this. I'll give another example. And these energies for the bonds, you don't have to memorize. These are standard values, fixed values. You don't have to learn. That will be given in the exam. Example, if I say nitrogen reacted with hydrogen and gives ammonia. And the energies for the bond, because nitrogen belongs to group 5, so there is a triple bond between the nitrogen. The energy, the value is 600, hydrogen and hydrogen 100, and nitrogen and hydrogen is 700. The first step, draw the structure to show all the bonds in reactant and product. So N2 means nitrogen bonded with nitrogen. And what kind of bond is there? Triple bond. How we identify it's a triple bond? Because it belongs to group 5. So it will share 3 electrons. That's why this is a structure for nitrogen molecule, or N2. Hydrogen is H2. So means hydrogen single bonded with hydrogen. But how many hydrogens are there? 3 hydrogen molecules. And NH3, nitrogen bonded with 3 hydrogens. And how many molecules of NH3 are there? 2 molecules of NH3. So first thing what we'll do, we'll draw the structure to show all the bonds in the reactant and product. Now, what happened? Reactant side, the bond will break. So to break this bond, how much energy is taken in? It's 600. To break hydrogen bond, each bond will take 100. This will take 100. This will also take 100. This will also take 100. So second step, you will calculate the bond breaking energy or energy which is absorbed from the reactant side. So calculate the bond breaking. How to calculate bond breaking? Because there's a nitrogen triple bonded with nitrogen and hydrogen single bonded with hydrogen. And how many bonds are there? 3. So this is 600 plus 3 multiplied by each bond is 100. So 3 multiply 100, 300 plus 600, that will give us 900. Is it clear this part? The energy which is absorbed or bond breaking energy. Any doubt till this point? So reactant side is always a bond breaking side. So first you have a reaction in which nitrogen is reacting with hydrogen, 3 hydrogen, and it is giving 2 ammonia molecule. So nitrogen N2 means nitrogen triple bonded with nitrogen because it's a group 5 element. So group 5 will share 3 electrons with each other. That's why there's a triple bond. And hydrogen group 1, so share 1 electron. That's why it's a single bond. So energy needed to break the nitrogen triple bond with nitrogen is 600 and hydrogen bond is 100. So there are how many hydrogen bonds are there? 1, 2, and 3. That's why it's multiplied by 3. So the total energy required to break the bonds in the reactant side is 900. Then you will calculate the bond forming energy. So how to calculate the bond forming energy? So product side, the bond will form so NH3, nitrogen triple bond, single bonded with. So how many each NH bond required 700. So this required 700. This release 700 because it's a bond forming. This release 700. So each bond is releasing 700. So how many NH bonds are there? There are 6 NH bonds. 1, 2, 3, 4, 5, 6. So this will be multiplied by 6. So each NH bond is 700. So 7 multiplied by 600, it will be 4200 kilojoule per mole. So this is the energy which is given out and this is the energy which is taken in. Which energy is more? Energy given out or energy taken in? In this example, which energy is greater?
Energy out.
Energy out. So basically, this overall reaction, because it will absorb energy, it will release, but the energy release is more than the energy absorbed. If energy given out or a bond forming energy is more, means this reaction is exothermic. So you will calculate the energy of the reactant bond and energy of a product bond and compare the energy change. Compare the energy change. If energy release is more, it means it is exo or bond forming energy is more. Always the product side is a bond forming side. This product side is a bond forming side and the reactant side is a bond breaking side. So you have to compare these energies and identify which energy is more. If a reactant bond breaking energy is more, it will be endothermic. If a product bond forming energy is more, the reaction will be exothermic. Is it clear now, the concept of energy in terms of or chemical reaction in terms of bond breaking and bond forming? I'll give more examples. You will have a better idea of the topic. But this is the way how we identify a chemical reaction from the bond energies. So first step, you will draw a structure to show all the bonds in reactant and product, then calculate the bond breaking from reactant, then calculate the bond forming from product, and compare the energy changes for bond breaking and bond forming to identify. Which reaction is this? Take the screenshot. Okay, example. This is a reaction. Propene react with bromine. This reaction is given. Use the bond energies. Calculate energy change. What is the formula for energy change? Energy change formula is bond breaking energy. This is a formula to calculate energy change. Energy change is bond breaking minus bond forming. So basically, first what we have to do, we have to calculate the bond breaking energy, and then we have to calculate bond forming, and the difference will give us the energy change. Less than a minute left, so I will continue explanation in the next session. I'll share the link once this will end. So what are the bond breaking reactant? This side is a reactant side. This is a reactant side, and this one is a product side. So reactant side, the bond will break, and the product side, the bond will form. So how many bonds are breaking? You can identify, like this is C double bonded with C, CH, 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 C